Okay class, here we go with some more stoichiometry problems. Today we're going to discuss how mass mole problems work. Our goal for this video is that you'll be able to convert to and from masses or moles of one substance to the mass or moles of another substance. So let's dive into this now. In mass mole problems, we're either going to be given the mass of a substance and have to solve for the moles of a product formed, or vice versa. In these problems, we are going to just follow the same steps that we would for our mass problems, ending after the mole ratio. Just like in our mass problems, let's use the building illustration to work through these problems. How many moles of sodium phosphide is formed from 53 grams of sodium reacting with phosphorus? We start off by creating a balanced chemical equation and labeling our buildings. Our balanced equation reads 2Na plus P yields Na2P. We name our building on the left sodium and sodium phosphide for the one on the right. We are given 53 grams of sodium, so let's place that in our mass portion of our sodium building. In order to get to moles of sodium phosphide, I'm going to have to convert my given mass of sodium to moles of sodium. Then I'm going to have to use the mole ratio to determine how many moles of sodium phosphide is produced. In order to convert mass of sodium to moles of sodium, I'm going to have to multiply it by 1 mole of sodium over the formula mass for sodium, which is 23 grams. Once we do this, we get 2.3 moles of sodium. According to our building, our next step is to take our moles of sodium and then multiply it by the mole ratio, which is 1 mole of sodium phosphide over 2 moles of sodium. Once we do this, we get 1.15 moles of sodium phosphide produced, and that's going to be our correct answer. Okay, hey, let's work another one, this time the opposite way. If we're given 2.3 moles of silver 1 oxide and it decomposes into silver and oxygen atoms, then how many grams of silver will be produced? Our balanced equation should be 2Ag2O yields 4Ag plus O2. If we label our buildings, the one on the left would be silver 1 oxide and the one on the right would be silver. This time we are given moles of silver 1 oxide, so we're going to put that in the mole portion of the silver 1 oxide building. We're wanting to find mass of silver atoms, so we're going to have to put a question mark in the mass portion of the silver building. Just following the illustration, we see that we're going to use the mole ratio bridge to get over to moles of silver, then use the formula mass to get 2 grams of silver produced. So first thing I'm going to do is take my given 2.35 moles of silver 1 oxide and put it over 1. Then I'm going to multiply it by the mole ratio, which is 4 moles of silver over 2 moles of silver 1 oxide. This gives me around 4.7 moles of silver produced. In order to convert that to a mass, I'm going to have to multiply the 4.71 moles by 108 grams of silver over 1 mole of silver. This gives me 507.6 grams of silver produced, and that is our correct answer. Okay, now that you have an idea how these are going to work, let's do one last problem. If I react 58.75 grams of bromine with carbon dioxide, then how many moles of carbon tetrabromide is formed? Our balanced equation should read this: CO2 plus 2Br2 yields CBr4 plus O2. Our building on the right is going to be carbon tetrafluoride, while our building on the left is going to be bromine atoms. We are given the mass of bromine, so we are going to put that in the mass floor, which is 58.75 grams of bromine. In order to get this to moles, I'm going to have to multiply the mass of bromine by 1 mole of bromine over the formula mass of bromine, which is 160 grams. Remember, bromine is diatomic, so we're going to have to double the atomic mass in order to get its formula mass if it's not bound to another atom. Once I multiply this out and divide it, I get 0.37 moles of bromine. Now I multiply it by the mole ratio of 1 mole of carbon tetrabromide over 2 moles of bromine, and I get 0.185 moles of carbon tetrabromide formed, which is our answer. Okay, now you should have a good idea how these work. Keep up the good work in the classroom, and see you next time.